Lesson 3.3, Proving Lines Are Parallel. In order to do this, we're going to be using the converses. Our essential question is, can you name the theorems that prove lines are parallel? Let's start with the first converse, which is the corresponding angles converse. We're not going to prove it in this chapter. We'll save it for another chapter. Let's compare it to the theorem that we've had before. Before we had a theorem that went like this. If two lines are parallel, then corresponding angles are congruent. In today's lesson, we're going to prove the converse. If corresponding angles are congruent, then the two lines are parallel. All right, notice that the conclusion is two lines are parallel, and that's why we're calling this proving lines parallel, because that's what we want to show. In the previous theorem, we already knew that they were parallel. All right, let's take a look at this example. We want to find a value of x that makes m parallel to n. Now, so far, we only have one theorem that we can use. If corresponding angles are congruent, then the two lines are parallel. So these are corresponding angles. If I can make them congruent, then I know the lines will be parallel. So I'll set 65 equal to 3x plus 5. So 3x is equal to 60 and x is equal to 20. Making x equal to 20 forces this angle to be 65. When this is 65 and this is 65, I have corresponding angles that are congruent, and I can make the conclusion that m is parallel to n. Let's take a look at another example. Is there enough information in the diagram to conclude that m is parallel to n? So far I can only use one theorem. If corresponding angles are congruent, then the two lines are parallel. Now, these aren't corresponding angles, but I know that if this is 75, this is 105. This is a linear pair, and a linear pair are supplementary. And now I have this angle and this angle, and these are corresponding angles, and they also happen to be congruent. So the answer is yes, m is parallel to n. And what's the explanation? Well, we've satisfied this theorem. Okay, explain why the corresponding angles converse is the converse of the corresponding angles theorem. So remember, the corresponding angles theorem goes like this. If two lines are parallel, then corresponding angles are congruent. And the converse goes like this. If corresponding angles congruent, then the two lines are parallel. We call them converses because we've switched the hypothesis and the conclusion. Now here are the other three theorems that will prove lines are parallel. We're going to use shorthand notation on these. If alternate interior angles are congruent, then the two lines are parallel. This one is if alternate exterior angles are congruent, then the two lines are parallel. And if consecutive interior angles are supplementary, then the two lines are parallel. All right, let's go ahead and prove one of them. Remember, the only one that we have so far that we can use, let me go ahead and put that as an asterisk. If corresponding angles congruent, then the two lines are parallel. Okay, so this is given. Angle 4 and 5 are congruent. Now I know that 1 and 4 are congruent because vertical angles are congruent. And again, there's this connection. So I know 1 and 5 are congruent by the transitive property of congruence. Now 1 and 5 happen to be these corresponding angles here. 1 and 5 are corresponding angles, and since they are congruent, I've shown that they're congruent, I can make the conclusion that the lines are parallel. If corresponding angles are congruent, then the two lines are parallel. Let's do another proof. We'll prove the alternate exterior angles converse. We're going to start off with alternate exterior angles, and we want to show that the lines are parallel. And again, the only one we have so far is if corresponding angles congruent, then the two lines are parallel. This one we can use. So statement 1 is the given. 1 and 2 vertical angles are congruent. And again, we have this connection happening. So by the transitive property of congruence, we have 8 and 2. 8 and 2 happen to be corresponding angles, and we have shown that they are congruent. So we can reach the conclusion that these lines are parallel by using the theorem. If corresponding angles congruent, then the two lines are parallel. All right, in this diagram, R is parallel to S, and angle 1 is congruent to angle 3. Let's prove that these lines are parallel. Okay, so my given is R is parallel to S, and I have angle 1 congruent to angle 3, and I want to prove that P is parallel to Q. All right, so number 1, I write R parallel to S, and angle 1 is congruent to angle 3, and that's going to be the given. Now, I know that these two lines are parallel, and so I know that angle 2 is congruent to angle 1. And that's because if two lines are parallel, and I had it right here, then corresponding angles are congruent. Now I see this connection here going on between 1 and 1, so I can say angle 2 is congruent to angle 3, and that's going to be the transitive property of congruence. Now 2 and 3 happen to be alternate interior angles, and we have just proved that that's true. So I can say, now that I know that alternate interior angles are congruent, I can say that the lines that they're formed are parallel. So P parallel to Q, and I'm going to use the previous theorem I just proved. If alternate interior angles are congruent, then the two lines are parallel. So in this proof, I've used both a property and I've used a way to prove. The transitive property of parallel lines. And remember the transitive property when there's a connection. Here these two lines are parallel to each other, so these are parallel. And we also know that these two lines are parallel to each other, and there's a connection between them. And this proof will show us that we can also say that this is parallel to this. And we'll do this as an exercise later. Okay, in this diagram we have some parallel lines. We know that this line is parallel to this line, and we know that Q is also parallel to R, so they're all parallel to each other. And we'd like to be able to find 8. So since all of these are parallel to each other, I know that P and R are parallel to each other. P is parallel to R, this transitive property I just talked about. So I know that this angle and this angle have to be the same, because if two lines are parallel, then alternate exterior angles are congruent. And since this is 115, the measure of angle 8 will be 65 degrees, because they have to be supplementary. And this is the end of the broadcast, or the screen.